Welcome to section 1.6 of chapter 1. We're going to talk in this section about the significant figures that we looked at in section 1.5, but this time we're going to use them in calculations because we need to know how many significant figures are going to be in our answer, or how accurate we can be, another way of saying that really, when we're doing different types of calculations. So everybody pretty much knows rules for rounding, but I'm just going to reiterate that. If you're going to, once you decide how many significant figures you have, you're going to drop some, okay? If the first digit you drop is 4 or less, then the next number is going to stay the same. If the first digit that you're going to drop is 5 or greater, then the last digit that you keep will be increased by 1, so you'll round up, okay? So, for example, if you have 8.423, like we have right here, get my pen right, 8.423, that's going to round to, if we do 3 significant figures, it'll be 8.42. If we're only going to have 2 significant figures, it would be 8.4. Okay? Now your calculator may have 100 decimals. That doesn't matter. You can only be as accurate as your least accurate measurement. So just kind of remember that. So for 14.780, if 3 significant figures, this time we would round up to 14.8. If we only wanted 2 significant figures, we'd actually have to round up to 15, because 14.78, if we're rounding to 2 significant figures, we can only have that number, and so that instead of 14.8, it would be 15. 3256, if we round it to 3 significant figures, would be 3260, and we have that O there. Why? Just to hold the place, because it's 3,000. Or if you put it in scientific notation, you wouldn't have to put the 0 there, because that 3 tells us what place it's in. And if we only wanted 2 significant figures, it would be 3,300, or 3.3 times 10 to the third. So just keep it in mind that, you know, the number may look funny, but you can only be as accurate as you can be, and so you can only report as accurate as your least accurate measurement. Alright, so here we have a number of grams, 3.1457 grams, and how would we round that? Alright, so take your time, try it, and then come back. So 3 significant figures for this number, let's see, that'd be 3.14 or 5. 3.14, that's 3, that is a 5, so it would be 3.15. If it's only 2 significant figures, we would round it to 3 point what? 1 or 2? 1, 3.1. Why? Because we don't look at this one, we look at the original number. And in the original number, the number beside that one is a 4, so it would only be rounded to 3.1 grams. And we should probably get in habit of going ahead and putting our unit spot. When we multiply or divide, the rule is that you can only have the number of significant figures in your answer as the number that had the fewest significant figures. Okay, so if you have a number like this with 4 significant figures and you multiply it by one with 2 significant figures, your answer can only have 2. Okay, because you got 4 here and 2 there. You can only be as accurate as your least accurate measurement. And so when you multiply those together on your calculator, you get 8.631. And so since I can only have 2 significant figures, I have to round that to 8.6. So I multiply 4 significant figures by a number with 2 significant figures, and I can only have an answer with 2 significant figures. And that's whether you multiply or divide. It's the one with the least number. That's what you go by. The second example, 21.5 centimeters times 0.3 centimeters divided by 1.88 centimeters. Let's look and see, what do? You figure out how many significant figures you have. Okay, we've got 3 in that one, we've got 2 in this one, and 3 in that one. So how many is our answer going to have? 2. That's right, because that's the lowest number. So when you calculate that, you get a nice big long number in your calculator, but you're not going to give me that number. You're going to give me 3.4 because that's got 2 significant figures. Third example, you have 6.0 grams and 2.00 grams. Now, when you divide those two numbers together, you get 3. Okay? What's the lowest number of significant figures? 2. Okay? Because those zeros, there's a decimal there, so those count. All right? And so this one has 3, that one has 2, and so you can only have 2. And so since you got a 3, you actually have to add the decimal point .0 so that you can have 2 significant figures in that answer. All right, so here's our learning check. This is your chance to do your calculation. I hope you have your calculator out or get your phone or whatever and go ahead and calculate this. All right, so what'd you get? I got 8.52 centimeters. I got centimeters because centimeters divided by centimeters leaves centimeters. So I got 8.52. It was my display, and is that right? Yeah, because how many significant figures is that? 3. And I got 3 there, 3 there, and 4 there. So I can only have 3 significant figures. Very good. Okay, so multiplying and dividing, you're going to have the same number of significant figures as whatever the least number was in one of your measurements. In addition and subtraction, it's a little bit different. In addition and subtraction, it's the fewest number of decimal places. Okay, so the fewest number of decimal places in this case. And so back in the day when we actually did this by hand, we'd line these decimal places up as you see in order to add them together. Some of y'all may still do that. Okay, most people just gonna put it in the calculator and smoke it, right? Well, if you put it in the calculator or you do it by hand, what you're going to come up with is the 66.102 grams, okay? And so you look back and you've got 3 decimal places, 2 decimal places, and 1 decimal place. So your answer can only have 1 decimal place. That's addition and subtraction. That's the rule for it. All right, subtracting 65.09, which has 2 decimal places, minus 3, which has 1 decimal place. Our answer will have 1 decimal place. All right, here's your learning check. Try it and come back. All right, I got 104.409, right? I can do that one in my head. All right, 104.409. Okay, so we had 3 decimal places and 1 decimal place. So my answer is going to have to be 104.4 milligrams. Is that what you got? Outstanding. That's it. These aren't so painful after all, are they? All right. If you're not too tired, move on to section 1.7.